All right, welcome to This Explainer. We are plunging immediately into a high-stakes, rapidly developing reality today, and that is the active May 2026 Hantavirus outbreak aboard an Atlantic cruise ship. Now, Hantavirus isn't a new pathogen, but as we're seeing unfold right in front of us, it's a poorly understood and highly lethal one when it finds the right environment. So today, we're going to break down exactly what this virus is, how it attacks the human body, and why global health authorities are treating this current outbreak with such extreme urgency. Okay, let's dive right into this timeline to get a sense of the rapid escalation here. On May 2nd, the initial outbreak was reported on a cruise ship out in the Atlantic Ocean. But here is the critical complication. Several U.S. passengers actually disembarked before the outbreak was officially identified. Obviously, that prompted the CDC to urgently notify state health departments to track these folks down. And by May 9th, the situation had escalated so much that the Director General of the World Health Organization had to directly address the people of Tenerife regarding the ongoing response. 50%. I really want you to keep this terrifying figure in mind. This represents the potential fatality rate for the specific viral strain identified on that cruise ship, which is the Andes virus. When a pathogen carries a literal coin-flip chance of survival for those who develop severe symptoms, every single hour of contact tracing and containment by agencies like the CDC and WHO becomes a massive race against the clock. All right, moving to Section 1, Inside the Suspect, Hantavirus Biology.
To truly grasp what we're dealing with on that ship, we need to transition our investigation and look really closely at our microscopic culprit. Hantaviruses belong to the family Hantaviridae, and structurally, they're pretty fascinating. They feature a negative sense RNA genome that's actually split into 3 distinct segments: large, medium, and small. Together, these segments contain between 10,000 and 15,000 nucleotides. But what's truly incredible is that these segments literally form into circles by bonding at their ends, all neatly packaged inside a protective lipid envelope. It is an elegant, highly evolved structure built specifically for survival.
And how did it evolve this way? Through a long-lasting co-evolution with specific rodent hosts. It's like a matching game. Different strains pair with different rodents. So the sole virus travels worldwide with the brown rat. The Pumala virus is carried by the bank vole in Europe. Over in the Americas, we have the Sinumbra and the Andes viruses. Because of this long co-evolution, these viruses easily evade the rodents' innate immune systems. They just live inside these animals completely asymptomatically, quietly waiting for a human target to cross their path. And, well, when humans do cross their path, the historical burden is staggering. Globally, we see up to 200,000 cases of hantavirus annually. To put that into perspective, between 1950 and 2007, China alone recorded over 1.5 million cases. That single country accounts for roughly 70 to 90% of the world's total burden for the renal form of this disease, largely driven by the Hartan and Sol strains. Which brings us to Section 2, the modus operandi, how it spreads. Now, what's really interesting about this slide is that there is a massive myth about how this virus actually jumps from those rodent hosts to humans. People always seem to think it spreads easily through the air like the flu, but it doesn't. Dr. Softer Ganaye aggressively busts this myth, pointing out you have to inhale virus-carrying particles released when rodent-contaminated materials are disturbed. It's not just lingering in the air for hours waiting for you like the measles. The real danger is physically disturbing rodent waste, urine, droppings, nesting materials, especially in poorly ventilated areas. That physical disturbance kicks the viral particles into the air just long enough for you to breathe them in.
And this brings us right back to our breaking cruise ship scenario. Ordinarily, once a human is infected with hantavirus, it stops there. We're a dead-end host. However, person-to-person spread, while extremely rare, is only documented with the Andes virus. Because the WHO confirmed the Andes strain on that Atlantic vessel, which is, of course, a highly contained, densely populated environment, the CDC is on maximum alert. It is literally the one strain capable of human-to-human transmission through close contact. Now, while the cruise ship presents a very unique crisis, let's briefly look at who's typically most at risk out in the world. More than 70% of certain hantavirus cases occur in rural areas. Heavy farm work, threshing, logging, sleeping on the ground during military exercises, or simply living in housing with poor conditions and high rodent density. These are the everyday activities that drastically increase your chances of disturbing those contaminated materials and inhaling the virus.
Section 3. The 2 phases of disease. So, once inhaled, the virus doesn't attack everyone the same way. And this brilliantly illustrates how weird this pathogen is. Your geographic location completely changes how the disease assaults your body. On the left, we have HFRS, primarily found in Asia and Europe. It attacks the kidneys, moving through 5 distinct phases, including severe kidney swelling and low urine output, carrying a fatality rate of 1 to 15%. But on the right, we have the American variant, HPS. This form goes straight for the lungs and heart. It starts off with flu-like symptoms and rapidly progresses to sudden respiratory failure. This right here is why the fatality rate skyrockets to between 30 and 60%.
But what is actually happening at a cellular level in both of these forms? The underlying mechanism is terrifyingly efficient. The virus predominantly infects the microvascular endothelial cells. Those are the cells lining your blood vessels. But here's the catch. It doesn't necessarily destroy them directly. Instead, it triggers your own immune system to completely overreact. This host-mediated response compromises the vascular barrier, drops your platelet count, and causes your blood plasma to literally leak out into your surrounding tissues. Whether that means flooding your lungs or swelling your kidneys, it's a massive crisis.
Moving into Section 4, Diagnosis and Defense. With the body effectively turning on itself, identifying the infection accurately and immediately is absolutely paramount. Because early symptoms look just like a regular flu, doctors have to rely on strict clinical methods to confirm the virus's presence. They're looking for specific IgM antibodies, a massive 4-fold spike in IgG antibody titers, or they'll use RT-PCR testing to directly detect the viral RNA itself in the patient's system. They can also use immunohistochemical results to find viral antigens in tissues. Accuracy at this stage is totally vital. Because if the infection progresses to the pulmonary syndrome, the numbers are grim. Starkly, 38% of people who develop respiratory symptoms may die from the disease. That single statistic really highlights the extreme severity of the pulmonary variant we are dealing with in the Americas, and exactly why public health officials move so aggressively when cases are detected.
And here is the absolute most sobering reality of this entire explainer. If you contract hantavirus, there is no specific treatment. There's no approved antiviral drug. And there is no vaccine. None. Once the virus takes hold, medical professionals are basically limited to supportive care, managing your hydration, resting your body, and treating the symptoms. In the most severe cases, advanced interventions like ECMO machines, which bypass the heart and lungs to oxygenate your blood outside your body, well, those are our last line of defense to keep a patient alive while their immune system fights the war.
Let's look at Section 5, Prevention and Protection. Given that medical science currently lacks a silver bullet here, we have to pivot to actionable takeaways to empower yourself with the knowledge needed to prevent infection in the first place. So the crucial point is this exact sequence of prevention. First, you have to control rodent populations and seal up buildings so they just can't get in. Second, if a space has been closed up, like a cabin or a shed, you must ventilate it thoroughly before you go inside. Third, when cleaning suspected contaminated areas, you gotta safely wet clean them using disinfectants. And step 4 is an absolute, non-negotiable rule: never dry sweep or vacuum rodent droppings. Doing that is exactly what aerosolizes the deadly virus, sending it straight into your lungs. So we leave you with this final thought. Hantavirus is heavily influenced by environmental changes like temperature and rainfall, which drive those rodent populations up. Combine that, agricultural expansion, with our modern, highly global mobility, and suddenly, a virus typically found in rural rodents is sparking a deadly crisis aboard an Atlantic cruise ship. The biological facts are clear, the risks are high, and the world is way more connected than it's ever been. So the big question is your region truly prepared for the next outbreak?